Here we go, booklet A. Question 1, what is the value of the digit 7? So what I like to do is to just pay attention to the digit 7, and if you look closely, that's in the 10,000s place. They're not asking for the place value though, they're asking for the value. So that is 70,000, number 3. Question 2, common multiples. Now, I do not bother with 2s and 3s. I start with the largest number here. Okay, so what do I mean by that? I'm going to list the multiples of 4. 4, okay, that's not what we want because it's not a multiple of 3. 8, well, it's a multiple of 4 and 2, but it's not 3. Next, 12, yes, it's a common multiple of all 3 numbers here. Therefore, the answer is 12. So again, to save time, I just list the number that is the largest. And then check one by one if they are multiples of all the numbers that we want. Question 3, no working required. Let's see the following. Which one is likely to be the height of a teacher's classroom table? The height. So when seated down, I don't think you want a table to be 1.5 meters tall, or 2 meters tall, or 2.5 meters tall. When seated down at the table, I believe the height should be number 1 meter tall. In fact, most of the time it's slightly under 1 meter. Question 4, which one of the following is the same as this? Now, if you understand fractions, 8/9 of 7, basically this word of here is multiplication. So that's exactly what I'm going to do. So 8/7 times 7, sorry, 8/9 times 7 is 8/9 times 7/1. And this here basically requires multiplying top with top, bottom with bottom. And if you observe, this is exactly what option number 1 is. Question 5, express this mixed number as a decimal. The fact that the denominator is 20 is very good because with 20, we can multiply it by 5, top and bottom, and we obtain 100 for the denominator. And with this, we can convert that to 9.15. What I like to do for these questions with the sum is to just convert all to grams and then neatly execute that vertical addition and therefore obtain the answer and convert to the required units. So if area of triangle, we are concerned with what is the base and what is the height. In this case, the base of this triangle is 15 plus 6. The height, which is the perpendicular height, is 8. So with the formula, it goes like this: half times base times height. Simplify this, 21. Half of 8 is easier to work with than half of 21. So that's half of 8. So that's 4. 4 times 21, therefore, is 84 square centimeters. And the answer, therefore, is number 3. Here we have a level 2 question. Now, let's see if DE is parallel to FG. If you look here, DE will definitely meet with FG. So clearly, number 1 is out. Which one is true, though? Is EF parallel to GD? Now, this is slightly trickier. If you look here, what I like to do is to look at the rise and the run. What do I mean by that? So if you look here, this is 1 unit down, 2 units right. Okay, for EF. Now, if they are parallel, I should have 1 unit down, 2 units right as well. Okay, let's choose this. 1 unit down, 2 units right. It's not parallel because I should by right see this. 1 unit down, 3 units right. The line should meet here. However, it doesn't. That tells me that these 2 lines are not parallel. So that's choice number 2 out. Next, EF is 90 degrees to FG. EF is 90 degrees to FG. Well, what you can do is to use your ruler or protractor to measure this. And what I realize is this is true. This is 90 degrees. Therefore, option number 4 is true. Alright, level 2. So how many nths? Now, notice that the same fraction appears a lot. 1, 6, 1, 6, 1, 6, 1, 6. And there's an equal sign here. So what I like to think of is this is the left-hand side. And then we have the equal sign. And this is the right-hand side. Next. Understand that this basically means 39 of these guys. 39, 1, 6. Okay. Now, because of this equal sign, what does that mean? We must have 39, 1, 6 as well. Now, doesn't this count as 1 of them? And doesn't this count as 8 of them? So the way I like to think of things is to say, okay, this represents 8, 1, 6. This represents 1 of them. So that's a total of 9, is it not? Now, because we want a total of 39, therefore 39 minus 8 minus 1 gets us 30. So this in the blank should therefore be 36. And the answer is therefore number 1. Question 10, order of operations. As you know, we have to work out whatever is in the parentheses first. And here we go. We got 2 times 0, multiplication done first. So that's 0 right there, leaving behind 3 minus 0, which gives us 3. Okay, then we'll work with division first, yeah? Leave the 6 alone. 15 divided by 3 is 5. Now finally, the last step, add them together is 11. Question 11, I like to basically write down the fractions or the decimals. So the way I do it is, number 1, 3,000s, okay, 3,000, 100, 100, 6 tenths. Now the fact that there's a th here tells me it's actually 6 over 10. There's a th here for hundreds, so it's 3 over 100. Now from there, do your addition. Okay, so it's basically 3100 plus 6 over 10 plus 3 over 100. Basically, this is 0.6, therefore this is 0.03, therefore here, and the answer is number 3. Well, for question 12, I like to use models. The sum of two decimals is 30. Well, that's two unknown decimals, right? The difference is 5.6. So using a model, I can do this. The sum is 30. The difference is 5.6. Is this not, okay, a 1 unit that we can solve for? Yeah, sure. Let's take 30 minus 5.6, getting us 24.4. So after getting rid of 5.6, we are left with 24.4 for 2 units. So for the 1 unit, the smaller decimal by the way, we'll take 24.4 divided by 2, and that's the answer. So we have 90 cents, $1.20, $3, and the ratio of F and all that. Okay, so by now you should know that we should work with the same units. Let's convert everything here to cents, and that's exactly what I'm going to do. 90 cents, 120, and 300. Find the ratio that F had to the amount that E had and C. So look, they gave you C, E, F, but they're asking for F, E, C. Well, before that, let's do a bit of simplification. Look at the 0, 0, 0 here. Well, we can simplify that, right? Let's cancel. That's this. And then all of them multiples of 3, which I'll divide by 3. And this is the simplest form. Then do not forget to write the ratio in the correct order. F, E, C. So this is max occupation, where you're basically finding out how much can I occupy in this space. And in this case, she wants to pack 100 1 cm cubes into a container. And she wants the least amount of space left over. Okay, so let's do this one by one, shall we? Now, do you agree 1 cm cubes? We're going to have 1, 1, 1, 1, 1, 1, 1, exactly 10 along the length. For the breadth, right, we're gonna have 2 exactly. And for the height, we're going to have 4. Well, we want 100. So look at the base area. It is 10 times 2, that's 20. So for 100, we will times 5 for the height, you agree? But the maximum here is 80, so you can't even fit 100. So number 1 is out. Next, 1, 1, 1, 1, 1, all along the base area therefore is 30. We can fit 30 cubes. But with a height of 3, we can only fit a maximum of 90 cubes. We do want to have 100 though. Next, while the base area here is 32, we can fit 32 cubes, and with height of 4, we can fit 128 cubes, which means 28 cubes worth of space empty. That's why I wrote here. Next, base area here, 8 times 5 is 40 cubes. With the height of 3, we can fit a maximum of 120. That's 20 spaces empty compared to 28 spaces empty. So we want the one that's the least amount of empty space. Therefore, the choice is number 4. So basically, when they tell you they are making such turns, and this is what he's facing after that. So where was he facing at first? You just do the reverse. So what do I mean by that? Start from working backwards, right? Start working backwards. So facing Z in the end. All right. Let's turn half clockwise. Okay. So from here, half clockwise. Let's go this way. And then from here, facing X, by the way, 3/4 turn clockwise. No. 3/4 turn anti-clockwise. Okay. So from here, we're going to go 1/4. Notice I drew these dotted lines to show a quarter. So that's 1/4, 2 quarters, 3 quarters. Therefore, he was facing Y at first. And now booklet B, subtract this from this. Now, do not take 1/5 minus 3 3/8. Nope. Take this from this. In other words, this is what you have. Take this away. So this is the correct subtraction statement, and therefore make the denominators the same. Subtract 15 minus 8, that's a nice 7. 3 holes minus 1 hole, that's 2 holes. And this is the simplest form, therefore that's the answer. Write down the decimal represented by the letter J. So the way I like to think about it is 2, 4, 6, 8 units represent 2 wholes. Therefore, 1 unit represents 2 divided by 8, which is 1/4. Look at J there. How many units is that? 1, 2, 3. So 3 1/4. What's that? That's 3/4. However, be careful of the special requirements here. So this is basically what I call special requirements. The question wants only one format. In this case, it's decimal. So convert this to 0.75 and Bob's your uncle. Express 106 minutes in hours. I do this as special requirements. Okay, so how many 60s are there? Well, the way I do it is this way. Okay, so 106 is made out of 60 and 46. Well, this represents 1 hour. This is 46 out of 60 minutes. Convert this to the simplest form. Okay, divided by 2, and therefore this is the answer. Write down the size of ABC. As you know, we have to start reading from the right with 0 from the right. So in this case, we'll start here, right? And then go all the way, and you know it's an obtuse angle, so it's definitely going to be 100 plus, right? And in this case, it looks to be about 1 to 7. That's it. Okay, so sequences, number patterns. Well, we've got a pattern here, 70, 71, 72, 71, 70. 70, 71, 72, 71, 70. So first you have to establish what's the pattern over here. And I realized that this is the pattern with 5 numbers in between. So that's my first statement. One group has 5 numbers. Okay, now imagine this goes on forever, right? I wouldn't say forever, up to 104. All right, so 1, 2, 3, 4, 5, all the way to 1004. So there are groups of 5 that we have to deal with. So the question is, how many groups of 5 do we have in 1004? So it's a division problem. Let's do that. And we realize there are 200 groups of 5 with a remainder of 4. Now, what does that mean? So eventually, we're going to get a group of 5. Imagine this is the 200th group of 5. And then the last one goes, okay, 1001, 1002, 1003, and 1004. Well, don't we have remainder 4? 4th number in the pattern. Therefore, the answer is 71. Remainder 4. Therefore, answer is 71. Well, given these prices, the highest and the lowest, what's the difference? Well, compare the values. Do not be tricked by the 7 here. This is larger than this. And this is the smallest. Okay, so take the difference. Vertical subtraction, do it accurately, and you should get this answer. Well, the first thing you should know for this question is that we are removing triangles. In other words, squares remain the same. Yes, okay. So they want the final ratio to be of triangles to squares to become 3:2. Well, what do we have right now? We've got triangles, 8 of them, 2, 4, 6, 8. We've got 4 squares right now. If the final ratio is 3:2, and we know the squares remain unchanged, then let's have 4 squares in the end. So I'm going to multiply by 2, multiply by 2. That's 6:4. Now, doesn't that tell me that a total of 2 triangles were removed? Well, that's the answer. This is one side unchanged for ratios. Gopal started his training in the morning at the time shown below. He stopped 5.5 hours later. Shown below, well, this is 7. Well, look at this. This is past 7, but not past 8. So it must be 7 something. 7 what? 7:30. So he started at 7:30 in the morning, and he basically had 5.5 hours of training. So let's go forward by 5 hours. That's 12:30 in the afternoon. And another half, that's 1 p.m. in the afternoon. Special requirements, 1 p.m. in 24 hours. So 1 p.m. is 1300 hours. That's it. PQRU is a square, find SQT. SQT being this angle right here. Well, we know that the angles for corners of squares and rectangles is basically 90 degrees. So 90 minus these 2 angles will get us 90 minus 72, which is 18 degrees. Well, don't let the large numbers scare you, okay? So let's have a simple example here. Suppose I come up with this. All right, so 10 equals to something minus 2. If you think 8, if 8 comes to your mind, imagine this, 8 minus 2 equals 10. No, 8 minus 2 is actually 6. So what is the right thing to do? It's the opposite of subtract. It's to add. So plus 2, 10 plus 2, that's 12. And 12 minus 2 thus give you 10. All right, we shall do exactly the same thing. So our working shall be, do not forget your special requirements, nearest 1000. We're going to take this $7 million plus number, and did I just say dollars? Okay, plus 321. And of course, with this, look at the number right next okay, to the thousands place, and this is larger than 5, therefore round up, so it's 7655000, nearest 1000. So for this, we're concerned with how many groups of 100 grams do we have in 1.2 kg. Well, to make a life easier, convert this to grams. And if 100 grams is this amount, 50 cents, then 1,200 grams must be multiplied by 12. And 0.5 times 12, 0.5 is quite a nice decimal because it's half, isn't it? So what's half of 12? It's actually 6. 6 what? $6. The bar graph shows how a household used this amount of water, 72 liters, for 4 activities. So the total must add up to 72 liters. Well, read the graph and I guess find out. Okay, this looks like it's 10 liters right here. So all the way here, 2, 4, 6, 8, 10. Okay, and then tally up with the lines, and there you go. You got 45 and 2 liters. Of course, take 72 minus everything. You should get 15 liters, and you must draw it accurately all the way from here. So 10, 11, 12, 13, 14, 15. That's it, and shade it. Question 28, we've got fractions all over the place. So An he starts out with 3 kilograms of grapes. He ate 12 actual kilograms. This is a subtraction of 12 actual kg from 3 actual kg. And his brother ate 1/4 of the grapes. Hang on, this is not in kilograms. This is in as a fraction of this. Okay, now to aid understanding, I'm going to use a model. Look at this. A total of 3 kg at first, yes. Half actual kilograms gone, so that's a subtraction. But this is a quarter of 3 kilograms. Now, please do not subtract a quarter, because that's not a quarter kilograms. So let's find out first what 1/4 of 3 actually is. It is actually 3/4 of a kilogram. Okay, with this information, we can find out how much was left. So take 3 kilograms minus half actual kilograms minus 3/4 actual kilograms. Not 1/4, by the way. So with this, make sure with subtraction that the denominators are all the same. So times 4, times 2, we'll get all this. Now just look at the numerators. 12 minus 2 is 10. 10 minus 3 is 7. So with 7 and over 4, therefore the answer is 1 3/4 kilograms. Nadia's mass is this. She is twice as heavy as her brother. Hang on, she has 2 units. The brother has 1 unit. So the brother must be, okay, half of that. So we're going to half this, which is a division by 2. So make sure that your long division is done accurately, and you should get 14.85 kilograms. So the area of the triangle is 18 square centimeters. Find the length of one side of the square. Well, how is this triangle constructed? Look at the base here. Well, this is one side of the square. Now, what's the height of this triangle? Let's draw this, which happens to also be one side of the square. So we know that we're going to take half times unknown side times unknown side. And the answer must be 18. Well, there are unknown sides. What numbers do we have? The only number you have is 18. Well, we can use guess and check. What do we mean? So half times the same number times the same number must give me 18. So guess and check. You can choose 1 and 1, 2 and 2, 3 and 3, 4 and 4. And if you keep going with half times 6, you will get 18. Now, what does the 6 actually represent? It will be the length of the side of the square. And that's it. This is the end of the paper. Hope you learned something and you have a great day.